Welcome back everyone, Patrick here, moving on to the next transformation of quadratic relations. We're now in this video going to talk about horizontal translations. Sometimes you'll see them called horizontal shifts. So it's basically taking y equals x squared and moving it to the left or the right. Now, just again as a review, ultimately where we're going to get to is where we're taking y equals x squared and then we are transforming it to be in this final format, right? And then we're going to have these transformation values a, h, and k. Now in the previous video, we talked about the a value in particular, just alone. So we were talking about y equals ax squared and what kind of a values you can have and how it's going to affect that graph y equals x squared. Well, when we're talking about horizontal translations or shifts, the transformation value that we focus on is the h value. Okay, so what we're going to be doing is in this particular video, we're going to forget about the other transformation values and we're going to focus on the h value. So the quadratics in this particular video are going to be in that format. Right? So there's like an a value of 1 here in front, which if you remember from the previous video means that there's no transformation in terms of vertical compressions or stretches or reflections in the x-axis. And then notice there's no k value, right? There's like a +0 over here that we're not writing. So we're strictly focusing on the h value. And the h value, fortunately, it's a lot easier to deal with than the a value because there's only 3 cases. Either we're going to have an h value that is greater than 0, so either it's going to be positive, it's going to equal 0, meaning that there's not going to be any h value, so that's not even a legit case there, or we're going to have a negative h value. So those are the only 3 cases that you can run into for the h value. If you remember an a value, there were different subcases for these positive a values and negative a values. Here, we just care if it's positive or it's negative. Now, if the h value is positive, what that means is that the parent or the base function y equals x squared, there is a horizontal translation or shift, right? You could see either terminology used, horizontal translation or shift, by h units to the right. Okay, so if the h value is positive here, then what that means is we're taking x squared and we're shifting it that many units to the right. So for example, if we have let's say y equals, let's say the h value is 5. Well, if we plug in 5 here for h, we'd end up with what? X minus 5 squared. Okay, so the transformation on this, we would say there's a horizontal shift or translation by 5 units right. Okay, so the way that would look, let's draw it up here. Just need some space. So if we got the base function, x squared, well, if we just take this function and we shift it to the right, it's going to end up being somewhere over here. Right? It could be closer to this or further, but it's going to be somewhere to the right of it. So we'd end up with a function like that. For example, so this would be x minus h squared, and remember this is if h is positive. Okay, and the vertex of this, if a function is in this particular format and there's no other k value, right, the k value is 0, then the vertex of this in general, it's always actually going to be, we don't have to write it for every case, it's just going to be h and 0, like that. Okay, so if it was y equals x minus 5 squared, we took this, shifted it by 5 units to the right, then this vertex here would be 5 and 0, but I'm going to write h and 0 to keep it general. Right, so if you have x minus 10 squared, the vertex would be 10 and 0, and the quadratic has been shifted 10 units to the right. Now, one thing I want to mention that's a little bit sometimes confusing, but you'll get used to it as the section goes on. So remember, this here is if h is positive. So in this particular case, notice that the h value is 5, right? It's positive 5, and if we plug it in here, we'll have x minus 5. And so even though the h value is 5, notice that there's like a negative over here. So a lot of times you'll be given something like this. You just have to remember that when you're dealing with the h value in particular, it's almost like you switch the sign, right? So if you see like an x minus 2 squared, in this case, the h value is positive 2, right? It's like the opposite sign because it's x minus that h value. That h is like in brackets, for example, right? So that's one thing to sort of get used to, right? It's only for the h value. When you have a negative here, if you just look at a quadratic in this format, then the negative, the h value is actually positive, meaning it's going 5 to the right. Okay, you'll get used to it as you do more and more questions, but something I wanted to mention, and that's just because there's that negative there that changes the sign of that h value when it's in this format. But when you're actually talking about the h value, it's the opposite sign. Okay, so that's the first case. That's if h is greater than 0, and then if h is equal to 0, well, there's no horizontal shift left or right, because notice you'll have x minus 0, which is just x to the power 2. You just end up with y equals x squared, right? So there would be no horizontal shift or translation left or right. You wouldn't even have to write that, right? If you ended up with an h value of 0 in a particular quadratic, like you'll see quadratics, let's say they'll have like a value of 3, for example, and then a k value of like 5. Notice that there's no h value. There's no x minus something. There's no bracket here. The h value is just 0, and so if you're describing the transformations on this, you wouldn't even mention anything about a horizontal shift left or right. You don't have to say there's no horizontal shift left or right, unless it's maybe like a multiple choice kind of question, and that's one of the options, right? You wouldn't even mention this transformation over here. Okay, so nothing happens if h is 0, and then if h is negative, well, you guessed it, it's basically everything is exactly the same here, except it goes to the left. So there's a horizontal translation or shift by h units to the left. Okay, now this one, it's a little bit trickier. So let's say we have an h value of like -4, for example. You got to be careful here when you plug in this -4 over here. Notice that the sign is going to change, because if you plug it in very carefully, right, you're going to have x minus that h value. That h value within that big bracket, it's like in its own bracket. So you would put like a -4 here, and that's going to be squared, and then a negative turns into a positive, like that. Okay, so as I mentioned here, notice that the sign is changing. H value of 5, over here in the bracket it's -5. Notice here it's +4. The h value is really -4 because it's x minus the h value. So it's like we're taking x minusing a negative value, which ends up being a positive there. Okay, so don't get confused with that. If you see x plus something, that just means that it's shifted that many units to the left, right? You're changing the sign. The h value is -4. Okay, and the way that looks, if we got x squared like this, right, that's the base function. Well, we're just shifting it to the left now, so we'd end up getting a function like that. This would be y equals x minus h squared. And in particular, that's when h is negative, like that. But the vertex, it would still be at h and 0. So notice that this vertex here, if you plot this in Desmos, y equals x plus 4 squared, what's the h value? The h value is negative 4. So you're going to have negative 4 and 0. Right? I know it's a little confusing thinking about these signs here and switching them, but as you do more and more questions in this entire section, it's just going to become second nature. But it's something students initially can get confused on, so just wanted to mention that. Basically, if you see something like this, it's a shift to the left, right? There's a positive here, it means the h value is negative. Shift to the left. If you see a minus, it means there's a shift to the right. All right, and those are all the different cases for that h value.